Okay, so one of the results of plate tectonics is volcanism. In fact, the reason we know where the plate boundaries are, in part, is due to the location of volcanoes around the planet, mapping them out. And a very prominent area of volcanic activity is right around the Pacific Ocean. It also is a very high area of earthquakes, but we'll talk about earthquakes in a separate video. But we call it the Ring of Fire. It's an area, like I said, it runs from South America up through Alaska over to Eurasia and then down into back toward the Antarctic plate again. There's a lot of volcanic activity through here. All right, a lot of volcanic activity. All right, an example of a very not popular, a very well-known volcano here in the United States was Mount St. Helens. All right, there is a little video here. I'm not going to show you, but you can, if you're interested, you can look it up and watch it. It does show a very good portion right here. I'm going to show you just a tiny little piece of it right here. Turn the volume down. Okay. If you watch real quick, this was triggered by a 5.1 magnitude earthquake, and then the north face of Mount St. Helens kind of gave way in a landslide, and so it erupted upward and outward. And you can actually see it. This was time-lapse photography of what was going on here. Okay, so I just kind of show what's going on. All right, so volcano, it's a mountain made out of extrusive igneous rock, either lava that's hardened or what's called tephra, which is lava that gets thrown into the air and it hardens into rock before it hits the ground. All right? An eruption is when you have gas, lava, rock that gets released out of the volcano. Right? It goes onto the surface or up into the atmosphere. Okay? All right. There are different magmas out there, and the different magmas make up different types of volcanoes. All right. You remember the terms felsic, intermediate, and mafic. Mafic magmas tend to be the most fluid. They're the thinnest. They're very high temperature. They don't have a lot of gas dissolved in them. And so these types of magmas create volcanoes that are not really very explosive. This would create like the Hawaiian Islands, where the the lava just kind of bubbles out of the ground and runs down the side. It's not really very explosive, which you think about as an explosive eruption. Whereas at this end, the felsic end, there's a lot of gas dissolved in the magma. The temperature is very low, which means it's cooler, very low, 900 degrees. It's still temperature is lower, which means it's thicker, and so it plugs up the neck of the volcano a lot easier, and then the pressure builds up behind it, and so you get a lot of very, very violent eruptions with felsic magma. Okay? Mafic magma, you don't really get violent eruptions. It just kind of bubbles out of the ground. Felsic, you get very violent, and if you're in the middle, intermediate, it could be either. It depends on what's going on. Sometimes it'll be a little explosive, sometimes it'll kind of bubble out, but you get a little bit of both. All right. All right, so here's our different types of material that we get from a volcano. All right. The first type is called pillow lava. Pillow lava erupts from fissures under the water. It cools, forms a crust. All right. And I do want to show you these because they kind of demonstrate what's going on here. So here you can see that's pillow lava. Notice it's still hot inside, but the cold ocean water makes it form a crust very quickly. But then since it's continuing to push, it breaks through and then cools again, breaks through, cools again, called pillow lava because it looks like a pillow, so to speak. All right, so there's that one. If it's not underwater and erupts on land, there's two different types, okay? The first type is very smooth, it's ropey-like, it's super hot and kind of thinner, so it flows really easily. This is known as pahoehoe, okay? Not pahoho, pahoehoe. And this is what Pahoehoe looks like. Okay, notice that? Very, very, very hot, thin, flows very easily, very quickly. Right? The darker part is where it starts to cool. All right, so that's Pahoehoe. And this other one, it's rough, chunky, it's cooler than Pahoehoe, it's thicker, it doesn't flow as fast. This is called A'a. All right, and this is what A'a looks like. This is all Polynesian, Hawaiian. Their language is a little Polynesian language, a little bit different. All right, so this is what A'a looks like. Okay. Chunky, a little bit cooler, flows slower. Now you could outrun this. All right. However, it's not, you're not going to stop it. If it ends up leaning up against your house is going to become instantly engulfed in flames. All right, but this is A'a from Kilauea. All right, so there you go, your three types of lava: Pillow, Pahoehoe, and A'a. We also have stuff called pyroclastic material. All right, pyroclastic comes from the Greek word pyro, meaning fire, and we already know what clastic means, right? Fragments. Okay, this is the solid material that comes out of the volcano. It comes out and then solidifies and it lands as a solid material. So we've got, volcanic ash. And don't let the name fool you. You don't let movies fool you to think this is like snow. This is really little microscopic shards of rock. Okay? If you breathe this stuff in, it's going to merge with the moisture that's in your lungs and it's going to suffocate you. All right? A little bit bigger than ash are what are called cinders, or lapilli, meaning it's Italian for little stones. And then even bigger ones, 2.5 inches and up, we call them volcanic bombs or blocks. Okay, this even looks like a football, throw a bomb in football, right? That solid material has a name, we call it tephra. So what comes out of a volcano is lava and tephra. Right? Tephra it's solid, okay, when it comes out. Right? Still very hot, but solid. All right, a hot spot. I showed you the hotspot on page 5 before. All right, real quick, I'm just going to throw this up here again real fast. Okay, hotspot of the little stars. Okay, you can see we got a bunch of them. There's Bouvet, St. Helena, Canary Islands, Iceland, Galapagos. There's a bunch of them on here. Okay, these are areas where magma is rising to the surface. Okay, magma is rising to the surface, but the plate over top is moving. This is what created the Hawaiian Islands. So, millions of years ago, this guy right here was way back here over this magma rising up to the surface, creating this volcano. And then it moved off as the plate moved, and then a new one formed. And then they moved off, and another one formed, and they moved off, and another one formed. And so you get progressively older and older islands until eventually they erode down and they're back below the surface of the water again. But we get progressively older and older and older volcanic islands, volcanic mountains here, as the plate is moving. They become extinct over here. This is an active volcano. These are extinct. They're no longer active because they're not over the hot spot anymore. All right, let's see if this thing works here. Let's see if I can kind of show. All right, so this kind of shows how the magma comes from deep inside the mantle and it rises up to the surface. We theorize that there's a bunch of these around the planet, and that's what's causing these little locations that aren't really associated with plate boundaries. Remember we said most volcanism is associated with plate boundaries. Okay. Let's go back right about here. Okay. These aren't associated with plate boundaries. So we're pretty sure that they're just an area of deep magma down inside that's rising to the surface and erupting. Yeah, we don't need the sound on that one. forward a little bit here. Okay. You can kind of see what's going on there. Notice how it's coming up, forming the island, breaks the surface of the water, or forming the volcano, breaks the surface of the water. It's called an island. Okay. And you can take a look at that in more detail if you're interested. All right. A couple pictures, just to finish off this video here. I had a student probably 12, 13 years ago who went to Italy, and over there they have a little museum, an outdoor museum. It's gated off, you can't get in, but you can stick your phone through and take pictures, camera through. And these are just some pictures of some casts that were made from molds. When they excavated Pompeii from after the eruption of Mount Vesuvius, they found out that Vesuvius erupted so violently and so quickly that the pyroclastic cloud that came down was so hot that it literally engulfed people and killed them pretty much where they stood, where they lay, where they sat. This is a little boy squatting down here. These are humans. They're not real, these aren't actual people. What happened was, as they were digging into the ground, they found a hole in the rock in the shape of a person, because the person got buried by the material, and then the body decayed away and it left a hole. Well, they filled the hole with plaster to make the mold. So these are plaster casts of the people. There's a person kind of laying down, looks like he's covering his face. This, break your heart a little bit, ready? This is a dog chained up to a post that got engulfed. All right.